In this module, we'll talk about the transition from architecting a network on premises to a network in the public cloud. Let's start by taking a look at a typical data center network. Application workloads are typically in the server farms layer, which is towards the bottom. The important thing to note here is that all these components and all these layers that are shown on the diagram are owned by you. You can control how packets flow. In other words, you own the data plane. It is not abstracted from you. Now, in a previous module, we had said that when going to the cloud, the center of gravity has changed. In on-premises, application workloads would go through these layers you see on the diagram in order to be accessible from the internet or to go out to the internet. But with some cloud service providers, applications become accessible from the internet the moment you give it a public IP. So in other words, in the public cloud, the world is flat. Constructs sit very close to each other. And whatever routing and switching is performed by the cloud service provider is done transparently, without your knowledge. In other words, it is abstracted from you. Just so that everyone is on the same page, let's distinguish these terms, private cloud, public cloud, and hybrid cloud. And we'll place them on two axes, the vertical being for control and visibility, and the horizontal being for abstractions and agility. A private cloud, just like your own data center, is hosted on premises. You have the most amount of control and visibility there because you own the entire stack. But private cloud is the slowest when it comes to responding to the demands of the application because you're dependent on the underlying infrastructure, which can be slow to provision. And in order to embrace DevOps, you need an agile environment. A hybrid cloud, as the name suggests, uses a blend of private cloud and public cloud. A public cloud is where multiple customers or tenants are hosted by a cloud service provider or CSP. So, for example, we have Amazon Web Services or AWS, Microsoft Azure, Google Cloud Platform or GCP, Oracle Cloud Infrastructure or OCI, and Alibaba Cloud. Now, these customers or tenants share the same underlying hardware infrastructure in data centers that the CSPs own. Although there are some options to reserve hardware for dedicated instances, it's mostly a shared infrastructure and a shared tenancy model. And what we are seeing increasingly is a shift from private clouds to public clouds, and this is mainly because public clouds are able to offer their services more affordably because they can reach economies of scale. So it ends up being more of an investment for larger enterprises. On-prem data centers and private clouds are expensive to maintain. So we see this drive to consolidate and move towards the public cloud. Now, within the public cloud, we have a few flavors. We have infrastructure as a service, or IaaS, and that is where the CSP takes responsibility for the compute, storage, and networking services. So let's say that you want to spin up a virtual machine. In AWS, it's called EC2. In Azure, it's called virtual machine. In GCP, it's called compute engine instance. They all come under the category of IaaS. The CSP abstracts the hypervisor and gives you access to the guest VM. And you are responsible for the OS on that VM and all the libraries, middleware, and applications on that VM. Platform as a service, or PaaS, is where services are managed for you. So you end up with a reduced level of control. For example, you can run a relational database service or platform without needing to install the underlying binaries or be responsible for hardening it or patching it or even ensuring its uptime. You just need to bring your own code. Software as a service, or SaaS, is for pure consumption of a service. You have absolutely no control and therefore no responsibility for the application. So, for example, Microsoft 365 or Salesforce. One of the most fundamental concepts to grasp when talking about the public cloud is that at the end of the day, it's just another data center. Or if you want to get technical, a set of data centers. Whether you're an operator or an engineer or an architect or manage a team or a C-level exec, you should always remember that a managed service in the cloud, whether it's a SaaS offering or a PaaS offering, resides on physical hardware in a data center, just like it did in on-prem. There's no magic there. The hardware infrastructure of CSPs is subject to the same limitations that you encounter in your data center. But the big difference here is that you're at the mercy of the CSP, and you have no control over the hardware that your application runs on. Data centers of CSPs are grouped together in regions. For example, US East 1 region in AWS, West US region in Azure, US Central 1 region in GCP, and Ashburn in OCI. And they offer a set of services in these regions. And when businesses build and deploy applications, they factor in the region closest to them, as well as the region closest to their end customers. And keep in mind, CSPs are always adding new regions across the globe, so the numbers on the screen might have gone up since this video was made. Now, within a region, in order to minimize the impact of a failure, such as from a natural disaster, CSPs have data center facilities called availability zones. AWS and Azure call it availability zones, GCP calls it simply a zone, and OCI calls it an availability domain. They all mean the same thing. They're engineered to provide high availability within a region, and they have very low latencies between them. Some CSPs have as many as 6 availability zones within a single region. Keep in mind that not all CSPs have regions with multiple availability zones. For example, Azure has a concept of availability set, which provides redundancy by means of multiple racks and multiple power lines. In OCI, the same concept is called a fault domain. Also note that CSPs randomize availability zones across accounts or subscriptions. So for example, for 2 different AWS accounts, what is US East 1A for one account may or may not be the same as for the other account. It might end up being US East 1B or US East 1C. But within an account, US East 1A will always be the same physical availability zone. Here are some services that are common to every CSP. Every CSP has some way, shape, or form for identity and access management. In Azure, they call it Azure Active Directory, which is completely different from Microsoft's Active Directory in an on-prem context. Google's definition of IAM is essentially who can do what to which resource. Every CSP offers core services such as compute, storage, network, and database. Within each service, there are resources, which we often term as constructs. A virtual data center is where all these resources are housed. In AWS and GCP, they're called virtual private clouds, or VPCs. In Azure, it's called virtual network, or VNet. In OCI, it's called virtual cloud network, or VCN. And each CSP provides a mode to connect from on-prem to the cloud via dedicated private circuit, or private path. When you're architecting an infrastructure in the cloud, networking opens up on all dimensions. You need to consider directions from all over, within a region, across clouds, from on-prem to cloud, from cloud to remote sites, from remote users who are VPNing into the cloud, egress from cloud to the internet, ingress from the internet to the cloud, and making sure that routing is handled in a deterministic manner correctly and securely end-to-end. And we'll cover all of these in this training. In the next module, we'll cover AWS Networking 101.